any time, and I will be reading the questions out to our speaker at the end of their presentations. So I guess we can get started right away. And with that, I would like to welcome Gadfly Stratton of U of Toronto Scarborough.
Okay, thank you so much for having me. Let me just get my screen shared. It's great to be here. Is my screen showing? I'm gonna hope it is.
Good.
Awesome, thank you. Okay, so my name is Noelle Gadfly Stratton, Gadfly for short. I go to University of Toronto Scarborough, where I'm a PhD candidate in environmental sciences, supervised by Nick Mandrack and Nicole Klink. And I'm going to talk to you today about some themes, some moments that came up during analysis of my data, these and then what moments that came up. And hopefully I'll share with you, you'll understand what I mean by those. And these and then what moments can represent sort of barriers to ongoing communication or even impact people's engagement with invasive species management. There we go. So engagement with stakeholders is really important for achieving our invasive species management goals, right? They give us more eyes and ears. Most managers do not physically have the capacity to have, their eyes on every centimeter of a region, that we rely on our stakeholders who are there locally to help implement our prevention and monitoring efforts. A lot of the time, they're familiar with novel pathways that we may not be. They might know of a way an invasive species could enter an area that might not be as familiar to people who are from outside the area. They have a personal connection to the area. It really means something to them, which is really important. And sometimes their support is needed to get funding, that sometimes just to get more funding or to implement something, you may need to be able to demonstrate that there is widespread support from, community members. But engagement with stakeholders can also be challenging. There can be different understandings of invasive species, what counts as an invasive species. Ask people whether a native species can be an invasive species. You'll get a whole bunch of different answers. There's, invasive species denialism is a whole other, a whole other can of worms. But so those can all, affect our engagements. They can have different expectations for management, what management means, what their goals are, what they expect managers to be implementing. And as a result, they can have different ways of talking about the topic of invasive species. So my dissertation research has looked at what are stakeholder perceptions of invasive species risks. So how do they define and quantify risk? What is a risk? What kind of risks do they care about? And what do they not care about? What do they think about management? What does that mean to them? What is successful management? And then what counts as engagement? So for instance, does social media count as engagement? Does a presentation like this count as engagement? Some people are, really strongly say that no, it doesn't, and others are just as strong in saying that yes, it does. And so that can also impact the ways that we communicate with these stakeholders and, whether they feel engaged or not. Also look at how these perceptions inform ongoing management practices and policymaking. So my research uses a mixed methods approach. I use surveys, interviews, and focus groups. The quotes I'm going to be sharing with you today are from my interview data. And I talked to a variety of stakeholders, including academics, policymakers, and publics. And it's chiefly those that have an interest in aquatic invasive species and in the Great Lakes region specifically. So that is my study area, just to sort of make sure that any differences in the way folks are talking about things are not due to, regional differences, that they're from really disparate locations. They're all located around the Great Lakes. So these and then what moments were themes of frustration that arose during my discussions with participants about management and engagement. And essentially the story goes that folks begin on the same page, they're in agreement up to a certain point, and then a gap in their understanding appears. And unfortunately, often when that gap is realized, that's usually when one of the people has already exited the conversation. And the other person is left just kind of realizing that they're actually very confused about what's happening and sort of, and then what? So I'm going to share with you some examples of what that looks like and what some of the impacts can be of those moments. So this first quote I'm sharing with you is from an individual who works with an invasive species organization that does a lot of work with community members, but also goes to these talks by government managers as well, and that they had reached the point where they didn't agree with tagging efforts in the United States for grass carp because they had initially thought it was going to be 50 fish total. And then they learned that it was actually maybe going to be 50 at any given time. And then they got confused about the details. What if they lose a tag or a fish dies? Do they just put another one back in? They had tried asking questions at different presentations where they had access to these folks. And they were just told that they're not catching very many of them, which led to further confusion where they finally said, what are your methods? Like, what is going on? So they reached this moment where they're like, so we tag all these fish. And then what? This confusion around these management methods can lead to stakeholders who might have started out supporting management efforts, whose whole job is to support management efforts in this person's case. But then they become confused or frustrated when they realize they don't actually understand what you're doing or why. So there's this gap that appears. And those kinds of gaps can appear for a number of reasons. You could have had a change of plans, especially in really, long-term management. You have to be really adaptive with invasive species. Sometimes things just change. The stakeholder may have had a lack of information, so they just didn't clearly understand the situation to begin with. Or maybe you as the manager just didn't explain it as clearly as you could have. But regardless of the reason, this sorts of confusion can lead to a and then what moment where support, like what support means, becomes really unclear. And then that can make them less likely to offer that support in the future. The next example I have is confusion around terminology. So this individual works with youth, so children, educating them about invasive species, which is so interesting to me. And so they were talking about catching sea lamprey in traps and talking about how we scoop them up and remove them en masse. And then got the question, so what do you do with them? And so for a lot of us who work with invasive species that, we say remove, but we know what comes after remove. We know what the and then what is, right? They're destroyed or eradicated or killed or whatever word you want to use. But it's not always clear to everyone, right? And as this person noted, that when you're talking to a group of kids who are animal lovers and nature lovers, that they're not necessarily going to fill in the blank that you've removed them and then destroyed them. That they're going to have this point where, okay, so we remove all these fish, and then what? Luckily, this individual was trained and, regularly encountered these sorts of questions and had that experience, and so is able to fill in the blanks for them. But what happens when that doesn't happen? Stakeholders might start out eager to learn about invasive species and then become confused by unclear terminology, euphemisms, or metaphors. We use an awful lot of metaphors in invasive species discussions, especially, battle and war metaphors. Not everyone necessarily has the same background to understand these euphemisms, these metaphors, these different terms that we're using, even just, industry jargon. And that confusion can lead to a and then what moment when they realize they don't actually understand what you're talking about any longer, and there's a big gap there. The third and then what moment I wanted to talk about is when confusion arises around management priorities. So this individual was talking about management and how they felt it was, very limited, and saying, I don't know whether that's just money. But I don't even think that's the case because we spent a lot of money to deal with this problem. The confusing thing for me was that we've given a lot of this money to universities to be able to develop ways of stopping them. And then they've done what we've asked. And then they said, hey, do you want us to try it out in the real world? And we said no. So was it just like a make work program? Was it just, I genuinely don't know. And so we can see this person, like, it's almost palpable, their confusion, their frustration at this, what were we even spending this money on? Where did this research even go? And to be honest, I've felt that sometimes with some research projects where, you hear about the research or you've even done the research and then it just kind of went nowhere. So you have this moment of, so we funded all this research and then what? So stakeholders might start out excited by new invasive species research discoveries. We hear about new things all the time that could be the next big thing, but they might become frustrated when those novel methods are never put into practice. There could be a lot of reasons why they weren't put into practice. Maybe, once it was tested on a larger scale, it didn't even work. There may have been prohibitive costs where it just, was never going to happen. Maybe there were negative impacts and it harmed native species. But regardless of the reason, they're just left with, what happened. If they're just left with that and no follow-up answers, no explanations, that frustration can lead to the and then what moment where they feel they've wasted their time, they wasted their money. We spent all that money on that other research you never used. Why should I continue donating? Why should I continue spending my time on this? And may become less likely to continue to provide support. And the last example I wanted to talk about is confusion about how to participate. So in this situation, we have an organization that helps educate the public about how to dispose of or like what to do when they encounter an invasive aquatic species. So in this case, it was grass carp. And they said that they, got questions like, okay, I catch one. Then what do I do with it? And that they were put into this difficult situation because they say, well, technically it's illegal to have it live in your possession by law, but DFO also wants the fish live. So you have to call and then they'll tell you over the phone, okay, hold on to it, we're coming. But if you can't get a hold of anybody, then what? That was sort of where the title for this talk came from. This person's just exasperation. If you can't get a hold of anybody, then what? Do you just put it back? They don't want you to put it back. And so this sort of loop that you get stuck in of not understanding, we did what you asked, but then what? It's unclear about what participation looks like at that point. If there isn't, a follow-up for if you can't get a hold of anybody, what are you supposed to do? So stakeholders might start out enthusiastic about invasive species management. That's the ideal when you get a stakeholder who's really excited to come and learn and wants to help with prevention and management, and they really want to get involved. But then they might reach a point where they don't know what the next step is. And you really don't want to leave them with, my only task was to call you and then you didn't pick up the phone. So, and then what? That confusion can lead to that and then what moment where they realize they don't know what to do. They don't know where to go for help. And it might reduce their likelihood of participating in the future because of that just barrier of frustration. So these and then what sentiments were a frequent source of confusion and frustration. This just like throwing your arms into the air kind of sentiment came through. And usually it was due to them being given an incomplete picture of events or an incomplete set of directions. This often hindered their ability to understand current management efforts, to understand the benefits of current management practices, to understand management priorities and how they fit into those, and to understand how they could participate in management action. So what can we do to help mitigate this? Well, the first recommendation I have is to be empathetic to stakeholders' confusion, that often people seemed frustrated, not necessarily from the fact that they didn't like the answer, but just that they weren't getting a straight answer. Even if the answer was, I don't know, the fact that, they would ask questions and seem to not hear anything back, literally just this, and then what? An empty void, essentially. So if you don't know the answer, empathize with that. Tell them you'll find out if you can, and that in the meantime, we're all trying our best. Here's what you do know. Focus on that positive. Frustration with an opaque system is not going to encourage participation. Optimism and hope that we can make positive environmental changes is what's going to drive participation and cooperation and collaboration. So be open with folks to prevent their curiosity from transforming into frustration. The second is to explain key terms. So again, we use a lot of euphemisms and shorthand in invasion ecology. Not everyone will always understand what those terms mean. So always check in with your audience to ensure that you're speaking at an appropriate level. So different stakeholder groups might have different understandings of what removal means, for example. So if we look at that example of, the children learning about invasive species, to them, they hear, removal, you pulled them out and then sort of question mark, what did you do with them then? We also had the example of the folks who know that DFO want them removed, but then, and then what? Like, what is removal a part of? What comes next? Then what? Not understanding that part can impact their ability to understand and participate. So make sure you touch base with them and fill in those gaps. Confusion can act as a barrier to future participation if it's not engaged with. So take the time to go over those concepts with folks who ask for clarification to make sure that they'll come back next time. So even if they're confused and frustrated, they know that you're a source of information and you'll help smooth things over for them. And reach out to stakeholders regularly and ask them what they want help understanding. So in that example of the organization, not able to reach DFO, they actually had an ongoing relationship with DFO where DFO reached back out to them to see what else they needed and provided them with, new messaging about how to properly euthanize the fish so that if they call and can't reach anyone, DFO can still, taught them how to save those biological components that they needed to conduct the tests they wanted to do. And they said, we just need clear call to action and messaging for what to do. So communication is a skill that we can always improve on, always. And if you discover afterwards that you've left a and then what in there, just come back and work with stakeholders to fill in those gaps.
You got about a minute left.
Okay, perfect. I'm just on my last slide. So in summary, engagement with a variety of stakeholders, it's not without its pitfalls. There's some challenges. Gaps in understanding can lead to those and then what moments where confusion and frustration can act as barriers to participation, but we can mitigate, smooth over those barriers by empathizing with stakeholders' confusion, explaining key terms, and reaching out to stakeholders to learn where they might need more help. And with that, I guess I'll take questions.
Thank you so much for your presentation. That was awesome. So nice to hear a different perspective about invasive species management. I know it's useful to think about these things, but we don't always think about them. First question from the chat. I wondered how you communicate with those that sense they are completely exhausted by continually making efforts and keep making mistakes, not seeing the results quickly.
So how I communicate with folks who keep making an effort and they're the ones making mistakes, or
yeah, and just not seeing results in the management efforts that they're doing.
That's actually a lot of folks from a variety of groups, the public, but also, academics, like researchers, managers, they all kind of have those frustrations. The main thing is just to empathize. If you have shared experience, feel free to, share that you also, have experienced those things, but that, there are, positive things coming. We have made, great strides and there's successes in certain areas and with certain species. Anyone who, feels despondent and like it's a losing battle, you can just point to something like, sea lamprey. Like we thought it was a losing battle and it was clearly not. It's not perfect, they're not gone, but clearly, there are strides we can make. So there's always, ways you can sort of show them the positive, but always good to empathize. You're not showing them the positive to dismiss their own negative feelings. It's just sort of getting them to look at it through a new way. I hope that answered that.
Yeah, and that kind of goes with the next question, unless you have anything else to add with it. Any ideas on how we can win back people or stakeholders that were discouraged?
I think you would have to communicate with those stakeholders to find out why they were discouraged, because there's a lot of, was it that they weren't being, spoken to, that they weren't getting answers when they ask questions? Then that could be, that would be one issue. Is it that, I wrote a paper recently on invasive species denialism. If this is a denialism issue, then obviously that's going to need to be approached differently. And it would depend on what the root cause of that was. It all kind of depends on why they've stopped, in engaging and stopped wanting to be involved in that. But the main thing to do is that you would have to reach out to them to find out why.
Awesome. And I have one more question. How do you push this information that you're doing and the psychology behind it to organizations and show them that it's useful to think about this kind of stuff?
Well, how I've pushed it, I guess I've tried to give as many talks as I can in different places, try to network with, folks in management and at different invasive species organizations and just sort of offer them, my research and hope that they, find it useful. You can't force anyone to find it useful. Maybe it's not useful, but, I try to make sure that my research is at least, available to them as much as I can. It's just sort of about like networking and sharing and being open with things as much as you can, I guess.
Great, thanks so much. Thanks again, Gadfly, for the presentation. It was awesome. There is another question in the chat about the paper on invasive species denialism, if you're able to pop that link into the Q&A. And there's also one more question in the chat if you're able to get to it. If not, if those people can email Gadfly their questions and they'd like to get back to it if they can. Thanks again. And with that, I would like to welcome our next speaker, Elizabeth Colby from the University of Illinois.
Hello, thank you. Let me get my presentation up. All right, is that showing up properly?
Looks good.
Thank you. Okay, so my name is Elizabeth Colby. I'm a postdoctoral researcher at the University of Illinois. And I'm looking forward to sharing some results from some research we've been doing about barriers to invasive species prevention. Our work takes place in the university or in the state of Illinois, but I'm hopeful that some of these implications will be relevant across the Great Lakes. So my work addresses the role of recreational anglers and boaters in the spread of invasive species, particularly this risk that possibly plants and animals can be spread via fishing boats and equipment as they move from one water body to another. So we're working with these various behaviors that boaters and anglers can do, specifically the clean, drain, dry steps. So cleaning the boat, draining water from the boat and allowing it to dry before entering a new waterway. So there's been a number of different outreach programs. You've heard about a lot of outreach programs today already that have been promoting the clean, drain, dry process. So there's been an increased awareness of invasive species among these engaged boaters and anglers throughout the region. We have found, however, that despite this increase in awareness, there's still a risk of invasive species spread that's still at high levels. So some work has been showing that a majority of boaters and anglers aren't consistently taking clean, drain, dry steps, whether they're not doing them at all or just not doing all of them or not doing them every time. So this research has also shown that boaters are frequenting multiple different water bodies. So this is specific to Illinois, but perhaps relevant across the region as well. So this network graph on the screen is showing how people travel from each little dot is a different water body. And so they're frequently moving between water bodies. And so it can be present a major issue if they're not engaging in clean, drain, dry steps between these trips. So we are interested in what types of psychological factors, specifically for people who are already aware of the issue, what factors are affecting whether or not they're participating in these behaviors. So one theory that we're working with, so we're conservation psychologists, so we're working with a conservation psychology theory called the health belief model. So according to this model, there are 4 different beliefs that are shown here on the left that are relevant in determining somebody's decision to take action. So we have perceived benefits. And so this is perceptions of what the positive outcomes will be from taking action. And so this includes things like supporting boat maintenance or teaching children about our influence on the environment, things beyond even just invasive species prevention. We also have risk perceptions, and these are beliefs about the threats posed by invasive species. This includes beliefs about the threats to the environment, to individuals, and to the community. Next is self-efficacy. These are beliefs in your ability to take action. So do people know what clean, drain, dry is? Do they know how to do it? Do they feel like they're going to do it correctly? And then finally, response efficacy is beliefs that the recommended behavior, that clean, drain, dry, will actually have the desired impact. So do people believe that if they do clean, drain, dry, they can stop invasive species from spreading? Or do they believe that it's not going to be very effective? And so the theory is that as each of these types of beliefs increase, people will become more likely to participate in prevention behaviors. So in addition to the different beliefs we reviewed, there's one more factor that we looked at that's really important in influencing behavior, and that is barriers. And so we use barriers to refer to anything that could prevent somebody from taking action. So to understand what types of barriers are most important for boaters and anglers in the Great Lakes, we held a few focus groups. And so we identified 5 key barriers that people reported as most relevant. So the first was lack of necessary cleaning equipment. So people talked about not having access to tools or resources that they would like to use to be able to clean their boat. Health or physical limitations came up. So people were concerned that they weren't able to kind of physically maneuver around their boat and reach all possible areas that might have plants that they wanted to remove, for instance. Having lack of time, just feeling that there wasn't time after completing a boating or fishing trip to complete clean, drain, dry. And kind of closely related to that issue was pressure from other recreationists to leave the site quickly. So if they're at locations, at boat ramps or sites where there's not really space to kind of pull your boat off to the side to complete these steps, that was presenting a major barrier for people. And then finally, poor weather conditions. So people talked about circumstances when the weather was poor, was turning poor, and so they wanted to just leave the site and not have to worry about steps. So in response to our goal with the study was to try to understand why boaters and anglers are participating in clean, drain, dry and why they're not. Looking at both those belief variables in our model, risk perceptions, benefits, self-efficacy, and response efficacy, as well as perceived barriers. So we conducted a survey. This was done online during the summer of 2021, and we were talking to boaters across the state of Illinois. So this map is indicating where all of our respondents were located. So we used a Qualtrics panel of people who had either gone fishing or gone boating anytime in the past 2 years. And we were asking them questions about how often they did, a list of different clean, drain, dry behaviors. And we also asked about each of the beliefs that I mentioned earlier. I do have a technical report available if anybody is interested in more specifics about the survey questions and the methods. But for now, I'll move on to the results. So first, to give you an idea of who participated in our study, our respondents were majority female, majority white, and an average age of 45. And we were surveying people who participated in both boating activities and angling activities. So a majority of people did both, whether they were angling from boats or doing some non-angling boating activities as well as angling. But we'd had a small segment who just did shore angling and didn't do any boating, and then a small segment who just did boating, which may have included canoeing or kayaking, and didn't fish. For the people who did fish, they're mostly interested in catching catfish, bluegill, and crappie. Okay, so moving on to the responses to our questions about beliefs and behavior. So each of these questions was asked on a 5-point scale. And so if they had answered 1, that would mean they disagreed or they didn't have high beliefs in that particular concept. And if they answered 5, that would mean they strongly agreed. So you can see that benefits, believing that there are positive outcomes to invasive species prevention, were fairly high. Risk was moderate. Self-efficacy, confidence in your ability to take action was moderately high, as was response efficacy, confidence that the action would be effective. And then the 2 boating behaviors. So we measured boating behavior separate, or clean, drain, dry behavior separately. So we asked people about cleaning boats in particular, draining water from boats, drying boats. There's a list of behaviors we asked about, and then separately we asked about what they did with their fishing equipment. And that fishing one also included proper disposal of bait. So the next thing we looked at was how these were related. How did the beliefs affect behavior? So looking first at boating. So this is the same model that I showed earlier. So we're looking at the influence of these different beliefs on the behavior. And so what we found was that somebody's intention to do clean, drain, dry on their boat was largely determined by their self-efficacy and their response efficacy. So this means that if somebody feels confident in doing clean, drain, dry, and they feel that clean, drain, dry is going to be effective, then they're more likely to complete the clean, drain, dry behaviors. So less relevant was seeing other perceived benefits of the behavior or being very concerned about the risks of invasive species. Moving on to the fishing-related behaviors, and we found similar results. Self-efficacy and response efficacy were both most important. And in this case, response efficacy, or feeling that clean tray dry will be effective, was the most relevant factor. Okay, so we also wanted to know if barriers would have an effect. And so we had learned about those 5 key barriers in our focus groups, and we asked our survey participants to respond to those barriers and report how important those barriers were to them. And what we had kind of anticipated was that there'd be some people who maybe thought that lack of resources was an issue, and maybe others thought that health was an issue. But we actually didn't find differences in that sense. What we found was that people in general, or people would either report that all of the barriers were a problem for them, or that none of them were. So people are either feeling really constrained across the board on different categories, or they weren't feeling very constrained by any of the barriers we asked about. So based on these results, we identified 4 key groups of people, people who reported that they were not feeling very constrained by any of the barriers, people who believed these barriers to be of moderate importance, people who found them to be high, and people who found them to be very high. And so what we did was we looked at our same models, looking at those 4 beliefs predicting behavior for each group experiencing a different level of barriers. So starting with the group who perceived barriers to be low, for this case, we found that benefits were actually really important. So if people are not feeling hindered by anything, then what's most important for them is just being familiar with what the positive outcomes of clean, drain, dry are. And so in these graphs that I'm showing, I have the boating related behaviors on the left, and I have the fishing related behaviors on the right. And so in this case, they were the same for both boating, clean, drain, dry actions, and then fishing, invasive species prevention. Benefits were the most important factor. Moving on to people who experienced moderate barriers. In this case, it's self-efficacy that was most important. So as people are starting to feel that there are a few things standing in the way of them doing clean, drain, dry, having that sense of confidence in their own ability is what's allowing them to overcome barriers. Moving on to the group with high perceived barriers. So as people are starting to be hindered by multiple different factors, and they're feeling these barriers to be more important, more other factors are needed to help them overcome these barriers. So for the boating behaviors, risk perceptions becomes important, self-efficacy, having the confidence in your own ability is important, and then response efficacy becomes important for this group. So again, response efficacy is that belief that taking action is going to make a difference, essentially that it's worth it to do clean, drain, dry, because you are going to be able to contribute to invasive species prevention. Similarly, for the boating behaviors, it was self-efficacy and response efficacy that were most important. Okay, moving on to the very high behaviors, very similar to the high behaviors group, we saw that risk perception, self-efficacy, and response efficacy were all important in enabling people to do clean, drain, dry on their boats. But when it comes to fishing equipment, it was only response efficacy that was playing a role. So for this group, for people who are feeling very constrained and feeling there are a lot of challenges to preventing invasive species via the spread of fishing equipment, what's most important in enabling them to overcome those barriers is just being convinced that it's worthwhile, that it will make a difference, that there's a reason to do clean, drain, dry. Okay, so I'm going to dive into a little bit more detail about what some of these results mean. So just to kind of recap the purpose of this study, what we were trying to do is look at why people are engaging in invasive species prevention and why they're not, and how barriers are preventing that action. So we found that participating in invasive species prevention was moderately high, but there was some variation, and that the decisions to do clean, drain, dry were influenced by a variety of factors, including risk, including confidence in your ability, and including beliefs that the action is going to work. We also found that the perceived barriers were really important in explaining the differences in which beliefs were most relevant. So looking at the different subgroups we'd identified, for the people who experienced very low barriers, it was just understanding the benefits of that barrier that was enough to inspire action. And so it might be helpful to highlight a variety of different types of benefits to appeal to people with different concerns and priorities. So some people might care mostly about just invasive species prevention. Others might care about side effects of supporting boat maintenance. Others might care about helping their community or helping get younger generations engaged in the environment. So just highlighting a suite of factors is likely to be most helpful in highlighting benefits. For the group that is experiencing moderate to high barriers, it was confidence in somebody's ability. And so self-efficacy, or this sense of confidence, is one of the most important predictors of invasive species prevention behavior. So this finding kind of provides support or provides for a number of the different ongoing programs that are aiming to raise self-efficacy and to teach boaters how to do clean, drain, dry. And so one simple example is the sign that's depicted here, where it's providing really clear instructions on how to do clean, drain, dry, explaining what each step means in very simple terms, and then even having some tools available. So other examples would be a number of the different programs that have volunteers or staff that are at boat ramps, really teaching people how to do this and helping them build their own confidence. And then finally, response efficacy is particularly important for people facing the highest levels of barriers. So if people are going to be able to confront these high barriers, they need to be convinced that taking action is worth it. And so response efficacy can sometimes be underemphasized in outreach programs, but what response efficacy really entails is showing why clean, drain, dry makes a difference. So not just informing that this is what you need to do to stop invasive species from spreading, but highlighting how this has worked in the past, what some success stories are, and why specifically these are the behaviors that somebody needs to do. And then also related to this issue, why one individual should bother even doing it when it may seem like the problem is so much larger. So also wanted to mention the differences between the fishing behaviors and the boating behaviors. So for fishing, for most, the general overall group of people, when we ask them about fishing behaviors, as well as when people are experiencing the highest levels of barriers, we saw that response efficacy was the most important factor. And so it might not seem for people who are fishing that like small pieces of equipment are really going to make a difference in clean, drain, dry. And so we suspect this is why response efficacy is so important, because it's really important for people to feel like they are going to make a difference, even though it seems like they have, they're bringing along relatively small pieces of equipment in contrast to, say, a boat. And then for the boating behaviors, we saw that response efficacy, in addition to self-efficacy and risk, were most important, because the boating related behaviors are seen as more challenging. And so all of these resources, such as wash stations, stewardship programs, having volunteers, all of these things will help to raise self-efficacy.
You got about a minute left.
Okay, so just to kind of wrap up, our big picture is that accounting for all of these different variables is important in trying to understand why people do or don't engage in invasive species prevention. Just wanted to acknowledge everybody who's been working on this project. We have collaborators from Illinois Indiana Sea Grant, as well as our team at the University of Illinois. And I can wrap up now. So thank you for listening. I'll be happy to answer any questions.
Great. We have time to read one question, and then if you are able to stick around and maybe answer some of the other questions in the Q&A chat. Our first question is, why did you choose the HB model over the theory of planned behavior model?
Yeah, that's a great question. So for this particular project, we're working pretty closely with Illinois Indiana Sea Grant. And they have a number of invasive species outreach programs. And so part of what we were doing that I didn't present on in this talk was evaluating some of their outreach programs. And so the health belief model is a theory that's a little bit more closely related to communication. And so that helped us to understand the campaigns they were working with, and in a way that the theory of planned behavior wouldn't, because that's a little bit less focused on communication.
Great, thanks. And yeah, if you're able to just stick around and answer some of the other questions in the Q&A box, that would be great. And thanks again, Elizabeth, for your presentation. With that, I would like to welcome our next speaker, Paul Venturelli from Ball State University.
Hey there, you hear me okay?
Yep, sounds good.
Awesome. All right, let me just share my screen. Okay. See that as presentation?
It's you. Oh, perfect. Looks good.
Yeah. Okay, wonderful. Thank you. A bit of a lag there. Okay, thank you very much for being here. This is a paper that's probably 12 years in the making. Sometimes people think it's easy to work with existing data, and it takes a long time. You know, this is 10 years of thinking and working with the data that culminated in this paper, and we're very excited. It's leading to newer things that I'll talk about toward the end. Unfortunately, I'll be giving this presentation today because the two graduate students who were involved and really drove a lot of the hands-on work were unavailable. So that falls to me. And the kind of the impetus behind this research is you know, in my lab, we're working a lot with app data and with alternative sources of data, online data, and kind of behind this overall blanket theme that a lot of our conventional methods, it's hard to get a lot of data that we need. So human movement data within the context of invasive species is a perfect example of that. We need the data, but it's really hard to collect those data by conventional means. So understanding how anglers are moving, and you can maybe do it at a state level, regional, local, but doing it at the scale necessary can be a challenge. And the wheels really got turning for me. I'm an avid cyclist. I also like fishing. And so those two worlds started to come together. And I cycle a lot, and I record my cycling on an app. And this is a heat map of all of the cycling that's happening within North America, logged through this app. And I found out that the company is starting to use these data in partnership with municipalities, with cities, et cetera, to develop cycling infrastructure. So it's being used not just for fun, it's also has purpose. So just to zoom in here randomly on Chicago, you can see, you know, there's areas where people are cycling a lot, in areas where they're not, based on this heat map, and you can zoom in and see if that infrastructure is serving the cycling community well. And so the wheels that got turning is, you know, can we maybe do this for fishing as well, because people like to log fishing on apps and other things. And so with respect to fishing, this was a 2015 paper that we published, where we started to think about this idea. This was a paper where we tried, you know, 4 or 5 different things within the context of fisheries science, and aquatic ecology, thinking, you know, kind of proof of concept. Can we do these things? And this is one of the things that we looked into is how are anglers connecting these lakes? And we said in the paper, this could maybe be used for aquatic invasive species. Now, this app was, there weren't enough data to really get into too much. And so we started looking around for an app. And long story short, we eventually fell upon the FishBrain app. This app started in 2011. I think at the time the slide was made, there was, you know, close to 2 million catches and almost 500,000 users, and those numbers continue to increase. And to illustrate that, although I'm not actually going to show it, I guess I'll just say it verbally. This is a map that we made with one of the first data transfers that we received. And if we try to make this map now, it would just be a giant blue blob, even though we have the pixel setting as at the smallest possible. That's just how much data we have available through this app, which is pretty amazing. So with this work, we had 4 objectives. We wanted to see how anglers were connecting lakes and how those compared to the natural hydrology connection by rivers and streams. Wanted to identify these invasion superhighways, where we think most of this travel or these pathways of invasive spread are occurring. Wanted to compare those to the existing distribution. So this kind of looking in the past and explaining past patterns, but also wanting to look ahead. Like, can we use these, can we operationalize these data in any way to start informing prevention, management, monitoring, et cetera, in the context of aquatic invasive species. There's certainly assumptions that we made with the data and considerations. One is that, you know, these data may be biased in the sense that anglers are logging more memorable catches. It's also not every angler who is using the app. They tend to be more avid and younger, although you could argue that avid anglers are the ones who are probably moving around the most. There's certainly errors within the app, within the data set, and some we could identify and correct, and others are just impossible. But one of the things to always think about when working with big data is that these errors tend to average out. So big data are messy, but the average tends to be fairly realistic, biases notwithstanding. So we started creating the connections within the data set. We focused on lakes and ponds only because rivers are complicated. They're linear features, and so it's hard to make those fit that into the framework of a connectivity network. We have some ideas, and we ultimately like to pursue those eventually. We looked at movers by a single user between two lakes, and then we summed across all of those and used inverse time weighting. So this is Lake A and Lake B, and this is angler 1 within our data set hypothetically, and this angler fished here on day 1 and then moved to on day 4. There was logging activity within the app on Lake B for 3 days later, I guess. And then the time weighting just acknowledged that if you move, on the same day, then you're going to have a very thick or high risk movement activity. And if you wait weeks, months, I think we went up to like 100 days based on the literature, then it's a pretty low probability of something spreading. So you can imagine this line getting very thick and thinner. And then it also gets thick because we summed across all anglers. So just a quick introduction to graph theory. What we ended up with is a network comprised of nodes and edges and also isolates, and the edges were directional. So the nodes are the lakes, the edges are the correct connections. We knew it's two-way flow, so anglers were moving one way or the other. Some lakes were isolated, although not, which I'll get into. A component is just a distinct network. So is it lots of little components or one large one or something in between? Any two lakes connected, that creates a component. Degree is the number of connections that are within that network. The density is the number of connections observed relative to how many are possible. And then a hub are these lakes that are super connected. So within a social media context, these would be like our social media influencers. And then the lakes would serve that purpose within the context of aquatic invasive species. All right, so we zoom in and we did this for the natural hydrology. And then we also did it for the anglers. This is what it looks like for the hydraulic connections, how lakes are connected by rivers and streams. And so this is a lake here. And that center just means that's the center of the lake. We just needed to put that somewhere. And the lakes and rivers are connecting the streams and rivers are connecting different lakes. It looks a little different when you look at the angler network. We had to reduce this because there are so many connections, but you can see that there's this lake here. It's got a center and it's connected to local lakes, but there's also lines going off in different directions, and those are longer distance connections. Most of the connections we saw were fairly local, though, within the app data. Okay, so that first objective, we wanted to make that comparison to the natural hydrology, and no talk would be complete without a table full of numbers. I'll walk you through this and just pick out the highlights here. One is the percent isolates. So I said that we had no isolates within or I alluded to, I did say that we have no isolates within the network that's described by the angler movement. And that is largely literally because we said that no lakes are allowed in our data set unless they're connected to some other lake. So we got rid of them. But we then looked at all of the lakes in the angler network and how they were connected naturally. And you can see that 61.2% of those are not connected at all. So that's just to the right of that red square, or rectangle, sorry. Percent of lakes in the largest component, remember a component is just a network, and 93.2% of them, so 84,000 out of the roughly 90,000, form one giant across the entire US one giant connectivity network. So that's very high connectivity compared to the hydrology network, where it's just 3.6% of lakes, and that would be a system probably connected a lot by wetlands and lake chains, et cetera. Last thing I want to point out is the reciprocity here, how the angular network is different, is that reciprocity means two-way flow. 41.2% of the edges, those connections, were in two directions, where that didn't happen in the hydrology network for the lakes we looked at, which makes sense. It's all just downstream flow, so it's unidirectional. So those are three key differences: a large network that's highly connected and two-way flow. We also want to try to compare things visually. We looked at the map. This is the hydraulic connectivity. I'll be honest with you, it's very boring. This is showing the different, what are they called? The major subbasins, or sorry, major basins, drainage basins within the U.S. They're not connected. They're not, by definition, right? It's a basin. And so the only connections occur maybe at the terminus, where one might flow into another. We tried to look at this connectivity and say, okay, what do the connections look like with these black lines if we did it for the anglers, and the map was just all black. So we had to move to something else, which is a beautiful, terrifying figure that really visually captures the connectivity here. And just to orient you to this, the outer ring here, all those colors, those correspond to the numbers in the hydrologic connectivity map. If we did this for the hydrologic connectivity, this would just be a ring with nothing inside. The things inside show all the connections among the different networks, and so they're highly connected. If we look at the number 4 here, that is the Great Lakes Basin, and 7 is the Upper Mississippi River Basin. And just to illustrate, you can see that 4 is flowing, that teal color, if you see colors the way I do, is flowing down to 7, and 7 is flowing up to 4. And so that just kind of demonstrates that these are connected hydrologically, and not connected hydrologically, but highly connected by anglers. So they're crossing over all of these watershed boundaries, to the extent that, with very few exceptions, every single one of these basins is connected to another by at least one connection. So this high connectivity. We'll then identify these invasion superhighways, where we think there's a lot of travel happening, where most of the spread is occurring. So we couldn't show a map of all the connections, but we did do this heat map where we looked at the connectivity density on a per kilometer squared basis. And so that's the heat map there, showing where all the connections tend to be. And then we've overlaid the major highway system of the United States over top of that. To simplify things later, I'll be showing this superhighway where it's colored. So the black will adopt the color of the pixels that are just immediately behind it. And we'll get rid of the white. And so this makes sense that, this kind of follows the US population, in the sense that the connections are where people are, right? You need people moving around for those connections to form. So where we have population density, we have movement, and where we have water within the United States, we also have a lot of movement within that. As you go west within the United States, fewer people, a lot more open, and also it tends to be drier as well, and fewer lakes. So remember, this is an analysis of connectivity among lakes. Third objective, we want to look back. And so we looked at both milfoil and mussels to look at their current distribution, how that relates to the superhighway. And so, like I said, now we can see the highway here, the superhighway as colored there. So those colors, or at least linear features, and then the circles are all known locations of, in this case, milfoil. The question here is, if the superhighway matters, if it's this movement by anglers that's driving it, we would expect to see that a lot of the known locations are very close to the superhighway, and that's shown by the data here in the table on the bottom right, where 75% of the lakes are within 30 kilometers of the, so 18 or so miles of the superhighway. So where there are people, there are highways, and where there are people, there are people are moving on those highways, and that's facilitating a lot of the spread of these invasive species. We don't travel far from home. We can see the same pattern with zebra and quagga mussels as well, where again there 75% are within 33.4, 50% of those infected lakes within just 13 kilometers, and so we found this was fairly striking. We also wanted to look ahead. This idea that can we use the data? It's not just, okay, yes, we know what's going on, but can we use these to inform future activities and optimize operations? This is probably the busiest map that I've ever generated or even figure in my career. And I'll just quickly walk you through it. We can see the superhighway. Those are the colored lines. The blue, the dots there are, in this case, dracaenid mussels. And we've added a new feature here where we have high-risk connections. What we were thinking was, this connectivity is fine, but it doesn't matter as much between two lakes that are already infected. What we really want to prevent are future infestations, especially if we've eradicated or tried to, and we want to just prevent those that propagule pressure. So we need to look at other lakes that are receiving, do they have a lot of connections where they don't have invasive species, but they're connected to lakes that are. And so we did that within by the county within the United States. We just found lakes that had nothing in them, no invasive species, and then what percentage of those were having these connections that we consider to be high risk with lakes that do. And so the darker that color on that grayscale, white means not an issue, and black means 100% of those lakes. And what we found, what we kind of call the invasion front. So, for the dracaenid mussels, you can see that they're trying to get into the prairies there. And then we can start to ask questions about why they're not invading there if there's a lot of propagule pressure, or questions of, do we need to, is this where we need to allocate resources to prevent future spreads? But it could be ecological, right? It could be that for ecological reasons, and maybe in Northern Ontario, they're just not catching on. We also see interesting patterns where, around the Great Lakes, for example, there's all kinds of propagule pressure. And so it could be in those systems, they're somehow resilient to, as I mentioned, maybe those ecological things that are happening. And we can zoom in and see some of these examples, just looking at some of these hub lakes, an example of a vulnerable lake where, Lake Pontchartrain, this is down in Louisiana, just New Orleans, effectively. I've been to both of these lakes. I was doing my postdoc down there. And Lake Pontchartrain has milfoil in it. It's highly connected. And so that would be a potential super spreader. What's interesting is there's also a lot of visitation to the Bayou Oak City Park, a lot of fishing in there, and it has no milfoil. This could be because they spray or treat, and we have to check that. But it's also interesting to note that whereas Pontchartrain has all kinds of boater access, there's no boater access to that pond. So it's just going to be shore fishing. So there's the potential to spread milfoil is going to be through gear, which I don't think gear is a major spreader of that milfoil. So we can get down and do sort of those kinds of things if we zoom in. Okay, so takeaways here.
2 minutes left.
2 minutes, you said?
Yes.
Perfect, thank you. We have these angler and hydrologic networks that are fundamentally different. Even if we consider these data to be highly biased, I don't think that's not something that's, I think we can agree on that. The superhighway is consistent with the current distribution of a lot of invasive species. We showed an example with 2. And these networks can be determined on a local, statewide, or national level. So we were looking at this kind of like from space, but you can certainly zoom in. But there is work that needs to be done. What's also interesting is, as we mentioned, this is a potential tool for optimizing the allocation of resources because they are finite. And so how do we use those for prevention, monitoring, and management? Last-ish slide, I think. Yeah, and I think the last one is the acknowledgements. We have some future work that's occurring now. It's funded. It focuses on upper Mississippi River Basin, Minnesota, and the Great Lakes states, where we want to do some validation by comparing local regional networks. Elizabeth showed that coal paper, for example. We have data from the same time frame, and we can see how the networks compare. So do that kind of validation at those smaller levels so that we can get more fine-grained and more confidence with actually boots on the ground kind of activities. I want to explore mobile location data as an additional means of estimating propagule pressure. So we're starting, actually started in January, a project to look at that. And then ultimately kind of build all this into tools and layers for this optimization that I've been mentioning. And we think that's really exciting and potentially helpful, where these data you can and this isn't just a one-off, but these are tools where you bring in the data, process them, and get these pictures. And so you can see how these networks, they're not just static, but they're evolving. and how they can be used so that we can evolve how we optimize the allocation of those resources and react to these. Another example would be to see how if outreach is having an impact and seeing how the networks form that way. Okay, that's enough. I want to hopefully leave time for some questions if that's possible. I'll just thank you very, very much. These are slides that represent this is an unfunded project. We now have funding, but these are the where all of the co-authors are from. Thank you.
Great, thanks so much for that, Paul. Unfortunately, we are short on time for questions. However, I will direct everyone to the Q&A box to leave questions for Paul there. And Paul, if you're able to stick around and answer them, you can just type your answer in the Q&A box. This is also a good time to remind everyone to please put your questions into the Q&A box and not the chat, as they're easier for our presenter to go back and answer afterwards and for us to see them.
I'll be on until the
Next,
top of the hour. Thank you.
Great, awesome, thanks. And his email is also in the chat if anyone is looking for it there. With that, I would like to welcome our next speaker, North Joffe-Nelson from the University of Illinois.
Hello, thank you. Paul, you've got a great lab logo.
Thank you.
Okay. All right. So thank you. My presentation is called Angler Preferences for Management of Aquatic Invasive Species in the USA and Canada. It's a discrete choice experiment, and I would like to acknowledge all the co-authors here because this paper was just published and it took a lot of collaboration along the way. So yeah. So let's see how I made. This is not an audience that needs an introduction to invasive species, but for what it's worth, in the Great Lakes, it's a very pronounced problem. So that's because of its biological as well as its political complexity, its cultural importance, and its economic value. It requires a special type of approach given its political complexity. There's a lot of different jurisdictions involved, which means decisions are being made at a lot of different levels, and they're all trying to utilize evidence to create good policy. And so the evidence that they need is going to be it's going to need to be situated from not just an interstate perspective, but an international perspective. And so what kind of evidence are we talking about? The graph on the bottom right here shows the number of invasive species introduced to the Great Lakes over the past 100 or so years. Oops, go forward again. And what tracks with that rise in invasive species? A rise in human activity. So AIS are spread by humans, as we all know. In the Great Lakes, this is usually as a result of commercial shipping traffic, but it also happens when anglers move their equipment from boat ramp to boat ramp, from inland waterways to the Great Lakes. Zebra mussels, as you can see, stow on the propellers of boats and even on their fishing equipment. So finding good policy solutions is going to require understanding what these anglers want to prioritize in this type of management. This is essential for gaining their buy-in, which will increase the likelihood that they'll go along with these policies. So how do we understand what anglers want out of these management regimes? We have to ask them, and to do that, we used a method called stated choice modeling. This is a statistically sophisticated game of would you rather. We basically ask respondents what they would rather see between one scenario or the other. It relies on utility maximization theory, which is just the simple assumption that people are going to do what's best for them to maximize their own utility. This is a method that's been used pretty frequently now in environmental fields because of its ability to elucidate this preference data, as well as do cool things like allow for the calculation of willingness to pay. So we get actual dollar figures, and spoiler alert, we did that. So we wanted to understand angler preferences to help prioritize management decisions in the Great Lakes in the context of invasive species. So to do that, we wanted to determine the relative importance of factors that characterize future fishing scenarios, right? So we asked anglers what kind of management policies they wanted to see, and we wanted to estimate their willingness to pay to realize those policies. And then importantly, we wanted to evaluate any differences there might be between anglers in the US and Canada, because it is a very politically complex situation. and we've got an international boundary running right through the region. So what did we do? We conducted a mixed mode survey of anglers of Lake Michigan and Lake Ontario. This was in 2019. We sent mail surveys and online surveys to anglers who purchased fishing licenses in Illinois, Michigan, Wisconsin, and New York in counties adjacent to the Great Lakes. That's our US sample. And for the Canadians, we couldn't get fishing license data over the international border, so we relied on a popular fishing app, not FishBrain, but Angler's Atlas. And we got a pretty good sample with that technique. So in this survey that we sent out, we included our stated choice experiment. This is our would you rather game. And we wanted to test the relative importance of 5 different factors that could characterize management scenarios. So we asked them if they wanted to see wash stations, and each of these factors was described by levels. So for wash stations, we asked them if they wanted no wash stations, voluntary wash stations, or mandatory wash stations. Each scenario had wash stations at one of those levels. And then we asked them about added cost per fishing trip in increments of 5 from $0 to $20. The amount of native fish ranging from a 20% decrease to a 20% increase. We asked about the impact of from invasive species, and that ranged from a minimal impact to a severe impact, and the quality of fish habitat from poor to excellent. So if you're sort of playing along here and you're answering these scenarios, each respondent answered 6 of these. There's 4 on the screen, but they answered 6. If you're sort of playing along here, and you're an angler who cares a lot about wash stations, you really wish there'd be wash stations at these boat ramps, you're looking at option A and you're thinking, okay, this is probably the scenario for me, but you're going to have to understand what sort of trade-offs you make. So you're going to be looking at a 10% decrease in the amount of native fish and severe impacts from invasive species. This gets to that trade-off component here. We want to know what anglers want to see from management, given that there are limited resources at play. So we wanted to know what was most important relative to other factors. So who were these anglers? In the US, they looked a lot like anglers from previous studies. So they were mostly male, mostly white, and over the age of 50. They had pretty good levels of education and moderate levels of income. Amongst the Canadians, they were more diverse, so less male, less white, and younger, but with similar levels of education and income. And what were they doing? They were fishing a lot. So 28 days out of the year spent fishing, with 40 years of experience among the US anglers. Among the Canadians, 32.5 days fishing out of the year with 36 years of experience. That's a lot. And some differences in target species. There's more interest in walleye and other sport fish among the Canadians, and more interest in panfish among the Americans. In terms of where they're fishing from, it was the exact same. There's only one pie chart here because the results were the same for both samples. Mostly fishing at the Great Lakes, but some inland waterways as well. All right, so here are stated choice results. This is my least favorite slide, but what's important here is all of the factors that we tested showed a significant capacity to predict the scenario chosen. So all of these factors were important to anglers. They all had an effect on the scenarios that they chose. And so what we did here is we tested country of origin as a moderator, and you can see the values at the lower end of the table are much less. So the differences here are not very pronounced. We can already see that. The one thing that shows up is that Canadians, and the way to interpret this is the difference of Canadians over Americans. So the Canadians had a greater preference for improving fish habitat. But to make this a little bit easier on the eyes, we converted these large values to probabilities. And so we can see here the probability that a scenario was chosen based on the presence of a factor at a given level. So if we're looking at habitat quality here, a scenario that had poor habitat quality had a very low chance of being chosen, about under 10%, but it went up to about 35% of being chosen among the Canadians here when it was an excellent habitat quality as part of the scenario. But the real story here in my mind is how similar both these lines are. So the running joke in the lab is that one group likes hockey, one likes football, but they both feel the same way about fishing. And so, like I said, we also estimated willingness to pay values using the added cost per fishing trip coefficient. And what we found was that anglers were willing to put their money where their mouths were. So you can see pretty modest levels of willingness to pay, but still substantial sums of money. So this is the dollar amount that an angler would be willing to pay in theory to go from one level to the next. So in the case of wash stations, let's say, I'll go back to the previous slide here, they'd be willing to pay, was it $8 or so to go from no wash to voluntary wash, so on and so forth. So what does all this mean? The main takeaways are that Americans and Canadians are very similar in their preferences for AIS themed management. So this is particularly important because of, like I said, the complex political situation that characterizes the Great Lakes. There's a lot of different states, provinces, and 2 entirely different countries that have responsibility for crafting these policies. And our data shows that these policies can pretty much be very similar between the United States and Canada. And specifically, anglers wanted to prioritize the availability of infrastructure in the form of wash stations and improvements to fish habitat. There was less interest in increasing the sheer number of fish. So we can maybe assume that this means less interest in stocking and more interest in having fish habitat. There's if I'm thinking to my own experience, it is definitely more fun to fish than to catch, if it comes down to that. And finally, anglers were willing to accept added costs to see these improvements. So those willingness to pay values were higher than in a lot of similar studies. And this may be partly a reflection of the high cost already associated with fishing on the Great Lakes. So a lot of our sample utilized boats. And so it could be that those relative to their overall costs, those willingness to pay values are not going to increase their trips that much. So I probably wouldn't generalize and think that people would be willing to pay that much just for fishing at a local pond or something. But among Great Lakes anglers, our data shows that they are willing to pay to see management intervene on aquatic invasive species issues. So to conclude, invasive species are impacting aquatic ecosystems, and they're spread by recreational anglers, which demonstrates the importance of human dimensions research to address these problems. Our refrain is that conservation problems are human problems, and that is definitely the case with invasive species in the Great Lakes. Further, fishery management agencies require insight on preference for management scenarios and management regimes. It's crucial for getting the support of stakeholders, especially when it's a diverse set of stakeholders from different political backgrounds, national backgrounds, state backgrounds. And the evidence generated for decision makers needs to reflect this complex scenario. So we need to continue to generate evidence that spans political boundaries, especially international ones, as it pertains to the Great Lakes. So I'd like to thank everyone that was involved in this research project. There are a lot of funders that contributed to this, and a lot of different hands that went into making this project possible. So thanks to everyone who was involved, and thanks everyone for listening. And I'm happy to take any questions if I've got any time.
Great, thanks so much, North. That was great. We do have time for some questions, so I'll read them from the chat. First question, in your stated choice results, did you offer choice for actions such as clean, drain, dry, dispose? Cleaning stations are not intended to replace such actions. There may be a bit of confusion here. Cleaning stations are for those who don't take actions because they want tools to take actions. Cleaning stations provide another layer of protection. Did you want to speak on that?
Yeah, so that's not something that our experimental design would have been able to address, because that is an action that anglers presumably should already be taking without extra management interventions. This was designed to elucidate preference for what sort of added implementations managers could provide. So wash stations was just one of those. Yeah, I definitely agree that we don't need wash stations because you can use a cloth and that's been shown to be just as effective as high pressure hot water. But at the same time, if it increases maybe going back to Elizabeth's presentation and her findings, if it increases either self or response efficacy, then it could be a viable path forward.
Great, thanks for that. Next question. Not super familiar with the stated choice method, but it sounds helpful for these types of questions. Is there an expected gap between stated responses versus behaviors practiced? Are there ways of capturing applied data for use with these methods?
Oh yeah, I have to imagine there is definitely going to be a wide gap between what people say and what they do. That's just the way it is. And we deal in R-squared values, as you can see, that are very low in general. So it's a very complex situation when we're talking about human behavior. It would be very interesting to compare this with some observed behavior data. And maybe that's a good idea for the future, is to see, say, if wash stations were actually implemented, if people use them to a great effect. I think there's some experiments already out there with that. But yeah, that's a great idea. It would be really interesting to compare those with our data.
Great, thanks so much, North. Once again, I'll direct anyone that has any more questions into the Q&A box. And North, if you're able to perhaps stick around for a little bit and answer the questions there, that would be great. And I thank you again for your presentation. With that, I would like to pass it over to Claire Marshall from the Royal Ontario Museum. I'll give her a few minutes and then we're going to present a film.
Hi, everyone. Hope everyone's doing super well today. Thank you for bringing forth really great topics in conservation and sharing your work. I actually have a pretty easy job today. I get to be the really cool supply teacher that is here to show you a film instead of talk to you for 15 minutes. So I'm really excited to share that. I, like they said, I'm from Royal Ontario Museum. I just finished an 8-month contract with them. It was meant to end in August, but thankfully they kept me around for a long time. And it's really, a lot of great projects have really come from my time with ROM. And my biggest one, Great Lakes Great Invaders, is a film about the threat of aquatic invasive species, particularly grass carp. So we've heard a lot of really great conversations about them already today. And I'm excited to share with you what I have found going and interviewing people like TRCA, DFO, U of T, alongside my director, Sofia Mendoza, who's also here today. If you have any awesome questions for her and about the directing and filming process, we love to hear those questions. And yeah, that being said, let's just get started and watch the film. Thank you guys so much for your time.
Resting on the shoulders of the Great Lakes, Ontario is filled with vast amounts of fresh water. Below the water surface, entire communities come to life. Spiny fishes, diving ducks, forest of vegetation, each plays a critical role in maintaining a balance in the food web, building habitat and filtering nutrients. But these species, and the waters they call home, are under threat, and scientists across sectors are working to better understand how to protect them.
There's about 35,000 species of fishes. I don't think too many people realize this, but if you add up all the rest of the vertebrates, so that's mammals, birds, amphibians, and reptiles, they don't even make up to 35,000. There's just way more fish in the world. So of course they're going to have a greater impact on the ecosystem.
When we don't respect freshwater ecosystems, we place a lot of things at risk. Freshwater is a scarce resource and probably the most important resource on the planet for sustaining human life. And so having these canaries in the coal mine, these fish communities that can tell us about the health of that ecosystem is really important.
And what they're telling us is not good news. Overfishing, habitat destruction, pollution, rising temperatures, these threats all negatively impact fish populations. But one of the biggest threats to native fishes? Non-native fishes.
I would say there are two criteria for invasive species. One, that it's non-native, that it didn't exist in a habitat historically, and two, that it's problematic.
It's one of the things that would separate invasive species typically from native species is that they can tolerate more things. They are more generalist. So they can come from a different habitat into the habitat that they did not evolve in, still find it just fine. Maybe even good enough that they can compete and outcompete native species.
There's just so many links in nature that are broken when we start altering the conditions in which these things have evolved over thousands and thousands of years. And that's what invasive species do. They break those connections down.
Some of the earliest introductions, not of fishes, but of other aquatic invasive species, largely smaller individuals, have occurred since the 1800s as a result of ballast water transfers.
While many invasive species have been introduced accidentally, recent introductions of non-native species are more intentional, like releasing exotic pets in the wild or using them to control pests. Some of these introductions have backfired. Exactly the case with 4 species of carps originating from Eastern Asia.
These carp species, each one has kind of a unique superpower, a unique ability that gives it dominance over other native fishes in the Great Lakes. And in an environment here where it escapes natural predation and natural parasites, natural disease, their populations can explode. And in very large numbers, they can impact the ecosystem in very significant ways.
In Canada, the species we're most concerned about is the grass carp, mostly because it has been spotted here in Toronto back in 2015. Thankfully, we haven't seen it since. They're also a voracious eater of plants and could do some real damage to our wetlands.
The main reason that grass carp were brought to North America in the first place is to help control vegetation in ponds, but often those ponds would be flooded and then the fish would get into the wild, and that's how we think grass carp became established in the Mississippi River. And then they started spreading from where they were initially established. And they moved upstream into the Illinois River, which actually is connected through a canal to the Great Lakes. And that's why we're really concerned about grass carp.
And we know they're close, right? They're now spawning in several rivers in Lake Erie on the American side. It's hard to believe they're not going to be coming up here, let's just say that.
If we were only concerned over grass carp alone. Scientists are closely watching 3 other species belonging to the same family, Xenocypridae.
Bighead and silvercarps consume phyto and zooplankton, and then by changing those zooplankton ecosystems, that can have trophic cascades throughout the rest of the environment. And then finally, the black carp consumes mussels, and we have a lot of endangered mussels within our Great Lakes ecosystems, and we definitely want to be mindful and try to conserve their health as well.
Collectively, these species have the potential to drastically alter the Great Lakes ecosystems.
They can make the whole food chain collapse. And what depends on the food chain? Everything that we value. It's estimated that the impact of the establishment of grass carp or any one of those invasive carp species in the Great Lakes could cost billions of dollars. In terms of loss to recreation, including aesthetic use of the Great Lakes, boating, fishing, you know, they're going to have tremendous ecological and economic impacts.
Invasive species are a direct problem that we have created and that we can solve.
Researching invasive species is an integral component of preventing their establishment. Dr. Nicholas Mandrak, a research biologist at University of Toronto, leads studies that are critical to making informed conservation management plans.
My lab, we have been doing research that identifies what streams would be suitable for the spawning of these invasive carps. This is where they're most likely going to show up first. So this allows DFO to prioritize where they're going to monitor for the early detection of invasive carps.
Dr. Paul Bizonek's study at the RBG Fishway focuses on how to physically prevent invasive species from expanding range.
Non-structured deterrents are one of the tools in the toolbox where we try to stop the movement of target species, largely invasive species, but still allow for the movement of water flow or human shipping and other transportations of goods. And so these tools can include sound and light, carbon dioxide or electricity, tools that produce a stimuli that the fish avoid, but don't produce a structural barrier within the waterway.
The Department of Fisheries and Oceans Canada takes a proactive stance, monitoring for the presence of grass, silver, bighead, and black carp prior to their invasion. They also partner with conservation authorities to monitor local watersheds.
When you get into that control and management phase, the expense involved with that is just exponentially more than stopping these different species from getting in the first place.
Electrofishing is one of the methods DFO uses to surveil the Great Lakes and surrounding watersheds for these potential invaders, focusing on areas most suitable for their establishment.
Electrofishing is a type of sampling method where we use electric fields to actually encourage fish to come towards our net. So as the electricity is moving out into the water, the muscles of the fish are actually kind of manipulated by this electrical field, and then that allows us to scoop them up.
DFO also uses pike, gill, and trap nets to perform monitoring surveys, allowing for the detection of juveniles that often escape the electrical field.
If they were to show up in the Great Lakes, that would be a big deal. So we would immediately be sending crews out and sampling, targeting high efforts into trying to find any additional fish and removing them.
When we fish, swim, and recreate in Ontario waters, we become part of the monitoring team. Posters can be found in marinas across the Great Lakes, teaching anglers and other recreational boaters how to identify and respond if they spot an invasive species.
Spend your time, read them, learn what could possibly be destroying, the body of water that you've grown up on or have fished in all your life.
The more eyes that we have out there looking for them and notifying authorities if you do see an invasive species, the greater chance we have to respond appropriately in an early enough time frame to actually stop that invasion in its tracks.
While the role of science in monitoring is important, so too is the role of education. At Royal Ontario Museum, we bring the classroom to life, teaching visitors how invasive species impact native wildlife and holding fish identification workshops. Imagine seeing the lake you grew up on filled with murky waters, home to only a handful of fish species and few recognizable natives. And the damage doesn't stop in the water, but flows into fishing, tourism, and outdoor recreation industries. These aren't tall tales, they're the reality in ecosystems where these species have established. Join us in protecting our waters. Our native fishes depend on us, and we depend on them.
Thank you everyone for watching. I think we have a few minutes before y'all run off to lunch if there are any questions.
Thanks, Claire. That was awesome. I'm going to just peek in the Q&A chat to see if there's any questions. Okay, there's one question. It's not related to the video, but it's just asking, has there been any detection of northern snakehead species in Ontario waters? So maybe either Claire, if you know the answer to that, or I can direct someone else to answer that question.
Yeah, someone else might have a better answer to that question. My role has mainly been, it's actually always been communications and very much Asian carp specific. So I'm not really sure exactly if we've caught, what did you say it was? What kind of fish?
Northern snakehead.
Oh, northern snakehead. Yeah, I don't know if there's a northern snakehead pro here that might be able to help that, but I can make a film for it if you want, if you have some communication budget.
Great. Any other questions? We'll just direct to Claire's email, which is popped in the chat. There's also a link to the YouTube video if you want to watch that video again or have it for your own records. That is also in the chat as well. Just before we go, I'm going to quickly touch a little bit on our Asian carp program. Thanks again, Claire, for the video. Sorry, I'm just going to share my screen again. Oops. There we go. Before we move to break, I'd just like to touch on our Asian Carp Canada program. Asian Carp Canada brings together information on the most recent prevention technologies, early warning measures, response efforts, and the overall threat of Asian carp to the Great Lakes and beyond. You can visit the Asian Carp Canada website to learn more. And with that, I would like to pass it back to Mackenzie.
Awesome. Thank you so much, Liana. And thank you to all of our speakers and all of our audience members that joined us through this morning. Please join us back in our next session for our plenary keynote presentation at 12:30 right after lunch. So please enjoy your next 30 minutes and we'll meet you back online at 12:30. Thanks again, Liana, for a great moderating morning.